Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for watching. Thank you for coming. We from group 2, we will share our presentation about one of the most versatile element on Earth. Before we start into topic, let us introduce ourselves. I am Arsi Sharif Shaini, and I'm collaborating with my teammates Ana Mauladiana and Eskiel Siringgo. We are from Mechanical Engineering 2B class. Today we are going to discuss about carbon and its various type of the carbon. Carbon is unique because it doesn't fall within traditional metal, ceramic, or polymer classification. To ensure technical accuracy, our discussion today is based on several key references. Our main source is from Material Science and Engineering and Introduction from William McAllister Jr. and David G. Ritschwitz, 10th edition. Carbon. The definition. Based on textbook we use, carbon exists in two allotropic forms, diamond and graphite, as well as in the amorphous state. The carbon group of material does not fall within any of the traditional metal, ceramic, or polymer classification schemes. This treatment of the carbons focuses primarily on the structures of diamond and graphite, discussion on the properties and applications, both current and potential of the diamond and graphite, as well as the nanocarbons. The next type of the carbon material. The first type is carbon fiber, polycrystalline diamond or PCD. Third is diamond, and the last one is graphite. The first, carbon fiber. Small diameter, high strength, and high modulus fibers composed of carbon are used as reinforcement in polymer matrix composites. Carbon in this fiber material is in the form of graphene layers. For what are termed graphitic carbon fiber, the graphene layer assume the ordered structure of the graphite, planar faller to one another, having relatively weak van der Waals interplanar bonds. Graphene sheets become randomly folded and crumpled to form what is termed turbostratic carbon. Graphitic fibers typically have higher elastic moduli than turbostratic fibers, whereas turbostratic fibers tend to be stronger. Furthermore, carbon fiber properties are anisotropic strength and elastic modulus value are geared parallel to the fiber axis, belonging to the other direction, then perpendicular to it or the transverse or radial direction. Because most of these fibers are composed of both graphitic and turbostratic form, the term carbon rather than graphite is used to denote this fiber. On the lower right is the structure of the carbon fiber, and beside of is product from the carbon fiber. Number 2 is polycrystalline diamond or PCD. A solid aggregate of many small diamond crystal or grains is used for some industrial application. This form of diamond is created by subjecting synthetic diamond powders to high temperatures and high pressure, similar to the HPHT technique used to manufacture synthetic diamond, a process that sinters the powders particles together and form a cohesive mass. The sintering temperature is approximately 1400 degrees Celsius and pressures on the order of 1300 atmosphere are required. Typically, PCD parts are manufactured as individual insert or pads that are integrated into the attached to multi-component cutters or bearings. This an attachment mechanism is required, which is in the form of a tungsten carbide, carbide substrate that is integrally bound onto the PCD insert or pad during its HPHT treatment. The substrate also acts as a durable base and provides mechanical support for the PCD. The lower right is a structure of the polycrystalline diamond, and beside of it is bearings, the sample product from PCD material. Next, uh, next Anna.
Diamond. Diamond is a metastable carbon polymer at room temperature and atmospheric pressure. Its crystal structure is a variant of the James Bond structure, in which carbon atom occupies all positions both Z and H. Each carbon atom has undergone sp3 hybridization so that it bonds tetrahedrally to four other carbons. These are extremely strong covalent bonds. The crystal structure of diamond is approximately called the diamond cubic crystal structure, which is a found for other group 4A element in the periodic table. At the bottom, ring is the structure form of diamond. Baseite is a sample product made from diamond material. Graphite. Another polymer of carbon graphite has a crystal structure distantly different from that of diamond. Furthermore, it is a stable polymer at ambient temperature and pressure. For the graphite structure, carbon atoms are located at corners of interlocking regular hexagons that lie in parallel basal planes. In addition, each atom for bending electron is delivered interline bonds are generated perpendicular to planes and are of the weak van der Waals shape. At the bottom, right is the structure form of graphite. Beside, beside is a sample product made from graphite material.
Thank you, Anna. So I will continue the section various carbon used in mechanical engineering. First, graphite. Technology that use graphite include lithium-ion batteries in electronic devices such as Tesla Model 3 and smartphone. Where graphite is used as an important material is the battery component. Graphite is also used in nuclear reactor technology. The example image, such as at Chernobyl nuclear power plant. In addition, graphite is widely used as electroduct in metal smelting industry that utilizes electric furnace to melt and process metal. The example image electroducts. And next, okay, diamond. Technology that use diamond in mechanical engineering practice include cutting tools in CNC machine, diamond tip lathe tools, grinding wheels, drilling tools, and polishing tools used in precision machining. Diamond can be used in this technology because it is extremely hard, has high wear resistance, and can maintain sharp edges for a long time, making it very effective for cutting, shaping, and finishing hard material with high precision. The example CNC machine and grading wells. Okay, next, polycrystalline diamond. Polycrystalline diamond or PCD is widely used in mechanical engineering practice, especially in machining and manufacturing process. Example include PCD cutting tools for CNC milling machine. The example image. PCD insert for lathe tools, drilling tools, reamers, and end mills used to machining materials such as aluminum alloys. The example image end mills, composite and non-porous metal. PCD is used because it has very high hardness, excellent work resistance, high thermal conductivity, and a long to life, which allow machining process to achieve high precision, smooth surface finish, and higher production efficiency. And the last, okay, carbon fiber. Carbon fiber is widely used in mechanical engineering practice because of its high strength, lightweight, and good resistance to corrosion. Example of its use include structural component is vehicles such as the BMW A8, the example image BMW A8, aircraft structure like the Boeing 787 Dreamliner, the example Boeing. Okay. Machine frame, robotic arms, automotive body, panels, and high performance mechanical parts. Carbon fiber is used in this technology because it provides a strong yet lightweight material that improve efficiency, performance, and durability in mechanical system. Let's complete my presentation for today. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. Goodbye.